Hello coders, welcome to my video. So in this video, we will see how the individual Dockers are interconnecting with each other and it will create a cluster of Dockers. So as you know, the Docker is a isolated container. They have nothing to do with the outside world at the beginning. Okay. So every Docker have its own IP, its own network namespace, and its own routing table. It also have its own networking interface. So we will discuss this part, what is called as a network interface. Okay, so without the networking, if we have two Dockers, for example, container A and container B, there will be no interconnection between the two. Okay, so when Docker networking comes into place, Docker A can communicate with the Docker B through network, through the interface, through the bridges, to the any switch, and these all interconnecting technologies will help the Docker to connect tightly with each other. So if you see here, this is a default networking that is created by the Docker when we create any container. Okay, so for example, here we have our host machine and this Docker 0, that is a bridge interface having an IP 172.17.0.1 that is being created in our host machine. So when we created Docker, it got this IP in the same series or the same subnet of the host machine. Okay, so if container A wants to communicate through the container B, as these all are on the same network, they can communicate. They can communicate through this to the internet as well. Okay, so this is a very basic default networking when we run the Docker container. Okay, so next we will see what are the basic networking commands that we should keep in mind while using the Docker. So the first, the most important one is Docker network ls that will list all the networks that Docker can take or it can communicate with that Dockers folks. And this is the actual command. And here we have Docker network inspect and the network. So whatever networks we'll get through ls command, for that we can get more info. For example, we have Docker network inspect bridge. So that is a network name we have created, and it will list all the details of this network in the JSON format. And now we have to create our network. So for that, we can use Docker network. Then we have create and then name. This is a custom name. We can create anything. For example, here we see Docker network create mynet. Okay, we can remove a network as well. Okay, so what all these networks are? That can be a bridge network, that can be a host only network, and maybe no network between the Dockers. Okay, and here we have delete all unused networks. For that, we can use Docker network prone. It will delete all the unused networks as well. So this is very lightweight plug and play thing that we can apply on our Dockers. Also, if you see here, you can run that network. For example, here we have Docker run network and this network name. And here, if you see, you can connect container to a specific network. Okay, for example, we have a Nginx this container, and we want this network mynet to attach to this Nginx so that our Nginx server will work through this network only. So that might be bridge as well. Okay, so this command we can use. -d is for background. Okay, and here we can add a container to an existing network. So Docker network connect this network and container ID. Okay, so for example, here we have an example Docker network connect. Then my connect, mynet. This is a custom network we have created, and this is the container name. Similarly, we can remove or disconnect our network to the container. So here we have the different type of networking which we will use in our Dockers to connect that Dockers to each other. So first is a bridge network technique in which uh, we have a bridge and these containers will communicate through that bridge and this IP is in the same range so that they can communicate with each other. So this is the default for our Dockers right now. So we have a Docker 0 that act as a bridge and through that we can communicate. So there is one more to that, that is a host network in which this container can only communicate with the host. the IP is only, communicating with the host only, so that these containers can be used as a monitoring type of apps and packet capturing. So in that type we can use this networking thing. And then we have some custom networks. We have the overlay networks also, in which we have different hosts, in which there is a cloud in between, which will as a network between the two hosts having different IPs at different location. And then we have demonstrate this thing where we have a local communication through the internet, through the routers, through the cloud, and there is a cross host communication as well. So these all networking, the basic networking techniques we can apply on the Docker as well. Okay. So I have created a script to demonstrate our understanding. So you will also learn a lot of new commands that can you use for Docker networking. So let's begin with that. Here, if you see Docker images, is nothing. Okay, and here we have network ls. So you will see these are the default networks that is available in the Linux Docker when you install it. Okay, so one is the bridge, the driver is bridge. Here we have the name host, the driver is host, and there is null. So nothing, they are not communicating with each other. So they may be used for some standalone apps, something like that, where security is a concern. Okay, so these all type of network we already have here. So what we do here is we have a script. I wrote a simple script to demonstrate this Docker networking. So it starts with a demo strat, and here we have check the existing network. We already did. We list the three networks here. Then we have inspect the default bridge network. We'll grab for the subnet. Okay, so we already see we have a bridge network as well as default. We'll grab that subnet. Okay, and the third step is we will run our Nginx, and we will give the name as web1 and web2 here. So this will run some containers of Nginx. So what we are going to demonstrate is, so we are running these two containers. Then what we will do, we these two containers by default will be running on the bridge. As you know, we have a default bridge network that will internally be connected with these two containers. Okay. And then we have Docker inspect hyphen F. And here we will list the IPs related to Web1 and Web2. So here we created the containers, and here we will list their internal IPs. Okay. Then this is the main part here, the step 5 for this demo. Here what we'll have, we have execute web1 ping hyphen c three times, and here we will work to. We are giving the name of these networks, okay, and we will ping from web1 to web2. So why we are pinging from web1 to web2 is they will resolve the IPs that is allocated to this. Okay, so there is a DNS server inbuilt to the Dockers that will resolve this web2 here. Okay, so in web1 it will run ping hyphen c3 web2, and you will get the result. Okay, next what we have is we have a custom network now. So for that, we'll start from the basic. Like we on in the first example, what we have is we have a default network bridge that is created already created there. So now we will create a custom network of the type bridge. So this will be a new bridge now. Okay, so we'll list this bridge as well. We'll see what is the output of this. So it will create a network mynet. Okay, and this is a custom network. So we will get the four networks after this command, and the fourth will be mynet. Okay, so what I will do here again, I'll run the container of a custom network now. So how to run a container for the custom network? We are not reusing the earlier Dockers, and here I will create a new instance of Nginx and giving the network as my custom network name, and have the name app1 and app2. Okay, so if you see here, this is some lightweight containers we are spawning in Docker, and this it will take 1,000 uh, microsecond to work for that. And then we have the container app1 and app2 are running on mynet after these commands. Then what we will do, we'll test the connectivity on the custom network. I'll do the same Docker execute app to this ping hyphen c3 to the app1. so that we are clear, okay, my custom bridge is also working. It's not about the default bridge that is working, our custom bridge can work properly. Then we will inspect our custom network through this Docker network inspect mainnet. Then at the last, what we will do, we'll remove everything. We will remove all the containers, web1, web2, app1, app2. And here, if you see, we have Docker network RM mainnet. So at the last, I'll remove my network as well, and demo will be completed. Okay. So I think you are clear about these two setups which we are going to do. Okay. So what I will do here, I close it simply. Then I run Docker network script, and then we will analyze the logs. What is there? So you see the Nginx servers are being fetching. So let's wait for some time so that our script got completed. Okay, so you will see your demo is completed here. Now I go to the start and we will analyze the logs here. So first we have a demo start. Then we have step one, check existing network. So here, if you see here, we have three existing network of bridge, host, and okay. And a step two, inspect the default bridge network. So we are grabbing the subnet there. So subnet should be 172.17.00.16. So this is a subnet of our default network. So next, what we will do, we'll run the two containers on default bridge. So unable to find the Nginx, so it will download the Nginx image, and then so you'll see container web1 and web2 are running on the bridge network. So the bridge network is the default network. After that, our Nginx containers are running on the default network. Our next part is check container IPs. So now we got the two containers here. Okay, before this IPs are for both the containers. So they are in the same subnet as the bridge network, which we have. So if you see here, we have a bridge network of 172.17.00. Okay. So next, we'll try to ping between the container using exe. So in step 5, we have to ping between the containers using exe. But here, if you see OCI runtime executable fail. Okay, so unable to start container process, ping executable, file not found. Okay, so in our containers, we don't have bandwidth for IP ping related binaries. So here the ping is failing between the two containers. Okay, so the first container is 172.17.02 and the second container is 172.17.03. Okay, so let's do one thing. So here, if you see, we have using Docker exe web1 ping -c3 web2. Okay, so in these Dockers, what we need to do is we need to install the ping binary. And for that, what I will do, I will add few more commands here. So Docker exec -it web1, that is name of this first container, and here I will do apt get update. Again, if I need to do another command, what I will do here, I will do install -y, then we have ip utils -ping this way. So same thing we need to do for web2 as well. So I will take web2 here. Okay, so both of the Nginx web servers now will have IP ping. I will execute that thing again. So see, it is updating. Okay, again, it got completed. I'll go to the same place to check whether our ping is working or not. So here, if you see, we have ping between the containers. The web2 name of service is not found. Okay, so if you see here, we have this web1 at this IP and web2 at this IP. It means maybe our default bridge is not resolving the DNS for this IP. So in spite of this, what I will do, I will take the names or the IP here. So web2 have 172. What I did here was just in place of the web 2, I'm putting the IPs of web 2 so that we can ping to that second this container. Okay, let's see if it works or not. Okay, so if you see here again, you see ping between the containers, step 5, you have 3 pings now. So it means the DNS is not resolved for the default network. So what for the custom network? So after that, on step 6, we have created a custom network. So once I created the custom network, mynet, it is shown in these sections. Okay, so as the name, mynet, and is a bridge type. Okay, now step 7, we have run the container or custom network. So if you see, we have containers F1 and F2 are running on mynet after that command. And now we have to test the connectivity of the custom network. And here, if you see, there is no such problem. We are pinging from F1 to F2 in a custom network. Okay, so step 9 is inspect the custom network details. So we have this mynet name and we have all the details related to this network here. Okay, so the IPv4 ranges are also there for this network. Okay, for app1 and app2 that is given by mynet to these containers so that they can communicate with each other. And lastly, the cleanup where we'll do all the cleanup. Yeah. Okay, so what? So here, if you see in this step 8, we are pinging from app2 to app3. So here, if you see in step 8, we are testing the connectivity of the custom network. In there, we will pinging app2 container to app1 and without any problem. On the network, this is a custom network. So our Docker is giving a place to create our custom network with DNS enabled. Okay, and here we are inspecting our mynet. Okay, so this is all about this video. Let's see in the next video. Thanks.